Hello, my beautiful students. I hope you're all doing well, having a great time, staying at home, and of course, staying safe. So, this is class 4 science lesson, and in this lesson, we will try to talk about electric current. So, this is class 4, unit 6, lesson 2. So, let's start. Of course, before we start today's lesson, we will do the section review in page 239. So the first question says, what is static electricity? Static electricity is an electric charge that stays on an object. You already know that static means not moving. So static electricity is an electric charge that stays on objects. The second question says, what is charge? Charge is the measure of extra negative or positive particles that an object has. So that is a charge. The third question says, what is electric field? Electric field is the space around an object in which electric force occur. So electric field is the space around an object in which electric force occur. So the fourth question is critical thinking. How can you make a piece of rubber that has an overall positive charge neutral again? So let me ask you a question. When you say this is a neutral, this piece has a neutral charge, when the positive and negative charge are equal, right? So the piece of rubber has overall positive charge, right? So you need to make it gain more negative charge in order to neutralize it. Okay, how can I possibly make it gain more negative charge? It's easy. The answer is by rubbing it against something. So your answer should be by rubbing it against something to get more negatives. Moving on to the test prep. A plastic rubber can get a positive charge by A. Gaining single negative charge, B. Losing a single negative charge, C. Gaining a single positive charge, D. Losing a single negative charge. So the answer should be B. Losing a single negative charge. Okay, let's talk about moving charge. You already know what is static electricity or static charge. You know that static charge stays on an object. But even a static charge will move if it has a path to follow. Now, I'm pretty sure all of us at some point we experienced this incident. So whenever you try to touch something and you get a small electric shock. Yes. For example, you have gotten a small electric shock from touching a doorknob. This happens. Well, how could this happen? Walking on a carpet rubs a negative charge off the carpet and onto your feet. So whenever you walk on the carpet, you rub some negative charge from the carpet and onto your feet. Now these charges spread out on your body. Now your entire body becomes negatively charged. And you know your hands is part of your body, so whenever you touch the doorknob, all the extra negative charge move at once from your hand to the doorknob. And what you get is a small zap, electric charge. So you can say that the static or non-moving charge has become a current. So what is electric current or current? A current or a moving charge is a flow of electric charge. Let's repeat this part one more time. So what is electric current? Electric current is a flow of electric charge. Don't forget this. Electric current is the flow of electric charge. Whenever the charge are moving or flowing, then we have an electric current. So what is a circuit? A circuit is the path that is made for electric current. And you can actually make your own project. You can make your own circuit. How and what should I use? Look at the picture. You can use a wire, just like in a picture, a bulb, and also you need a battery. A battery is electric cell. So what you need is a wire, a bulb, and a battery. And you can make your own electric circuit. So this is your homework. Each and every one of you will do an electric circuit just like that for me, and you can take a picture of it and send it to me. Now, of course, if you have all the necessary tools at home, and I'm pretty sure every home has those tools, since it is just a light, a small light could do the job, and a wire and a battery or electric cell. So the electric cell is very important for this project. Why? Because it supplies energy to move charge through a circuit. So what does electric cell or battery do? It supplies energy to move charge through a circuit. Don't forget that. There's another thing in the image in front of you, which is a row on the wire that tells you the plastic covering of the wire is an insulator. So remember, every wire or every conductor is covered with an insulator, which is usually made of plastic. Let's talk about how we control a circuit. So you already know that a circuit with a battery, bulb, wires contain different materials such as copper and plastic. For example, the wires are covered with plastics covering, right? While if you cut through the plastics, you will see the copper. Now you classify these materials by the way they control the flow of charge through them. So we have conductor. What is a conductor? A conductor is a material that current can pass through easily. Electric wires are made of metal. The base of a light bulb is made of a metal because it must conduct an electric current. Now, on the other hand, we have materials that do not conduct electric current, or current cannot pass through easily. These materials are called insulators. Insulators, a material that current cannot pass through easily. So that is insulator. The plastic covering of the light in front of you is actually an insulator, as you can see. Also, as we said in a previous slide, the plastic covering insulate the wire that you're going to use in your project. So what does the plastic do? The plastic keeps the metal of the wire from touching other metal. So it separates the metals. Another important part of this circuit is the switch. Switch use conductor and insulator to make and break the circuit. When the switch is on, two conductors touch. When they touch, the path is complete. The current flows through the circuit. When the switch is off, air separates the two conductors. Breaking the path, no current can flow. You know that you repeat this process anytime you switch a light on and off. Another part of a circuit is a resistor. What is a resistor? A resistor is a material that resists but does not stop the flow of the current. A light bulb is a resistor. A flashlight bulb contains a tiny coil of metal This coil is a resistor. Now let me explain another part. As the charge moves through the resistor, what happens? They transfer thermal energy to it. So the metal becomes hot. We mean coil metal. So the metal as it becomes hot, the glowing coil transfers some of the thermal energy to the air as a radiation. Of course, you remember this. It gives off light. Let's talk about the two types of circuit. The first one is parallel circuit. A parallel circuit is a circuit that has more than one path along which current can travel. So the current has more than one path to flow through. Now, I want you to count them. In this type of parallel circuit, we have two, but we could have more or less. So the first question says, how current move through a parallel circuit? Part of a current move through each path of a circuit. That's how the current move through parallel circuit. But what happens if I remove one of those bulbs? What will happen? So if bulb was removed from this circuit, the current still moves through the other path. So the second bulb stays lit. Now we can see this kind of circuit in our home, in every room. If one of your bulbs got burned, the other one or the other bulbs will stay on. Moving on to the second type of circuit, which is the series circuit. A series circuit is a circuit that only has one path for the current. So as you can see, we have the cell, we have the wires, and we have two bulbs. What will happen if I remove one of those bulbs? Well, since the current runs from the battery to the bulb, then to the next bulb, then of course to the battery, if you remove the first bulb, you will break the current. In another word, the single path is broken, no current move through the circuit. As a result, the second bulb will go out too. So remember, in this circuit we only have one path for the current, and disconnecting a light bulb opens the whole circuit, so both bulbs go out. Remember, if you removed one of the bulbs or one of the lights, both light bulbs will go out. Now, looking at each one of those short videos, you will understand something. For example, the first one on the right talks about the series circuit, while the one in the bottom talks about how the switch works. The third one actually about how the current flows through a parallel circuit. We reached the end of this lesson. Of course, thank you for your attention and thank you for your time. And your homework will be page 245, reviewing 245 beside the project, the circuit project. So thank you and good luck.